Ms. Connolly started making math videos for my own students, and this one's for them because it's a 5th grade video, and decided I wanted to share with everybody so we could get as many students learning as possible during this crazy time. So if you have a question and you need help, please send an email to connollymathathome@gmail.com. If you feel you've learned something, please like, subscribe, and share with a friend. Get as many students learning as possible during this crazy time. Okay, so today for math time, we are going to think about multiplication. And today we're going to be tackling multiplying with decimals. If you are in my class, this is right where we left off. We started some lessons about this right before we left, and so we're going to pick up where we left off. So let's get started. We're going to give our story problems a context, and we are going to say that we ran, Miss Connolly can do the running if you want, 3 days in a row, and I ran 5 miles each day. Okay, so I did 3 groups of 5 miles. And you can probably predict that my product is going to be greater than 3 and greater than 5. So you also know this math fact. If you didn't know 3 times 15, if you didn't know 3 groups of 15, you might have thought about repeated addition. You might have said 5, 10, 15. So you added 5 3 times. So you have these strategies with whole numbers. You've got a lot of strategies with multiplying whole numbers, and you know it. And we're going to use those same strategies when we're multiplying with decimals. And we have to be thinking about the size of the product so that we can figure out where that decimal point goes after we calculate. Okay, so there's going to be some estimating involved, and that's what we're going to do next. So, what if I get tired and I'm like, all right, those 5 miles are out the door. I'm only going to run 5/10 of a mile each day. I want you predicting how much about do you think that I ran that day. So I want you to do an estimate, and I don't want to cry, but I miss doing closest estimate with you all. Anyways, back to what we were doing. 3 groups of 1/5, or sorry, whoa, 3 groups of 5/10. And I'm thinking, well, I know that she ran less than 1 mile each day, because 5/10 is less than a whole. And I know if this was 3 times 1, then I would be at 3 miles each day. But she's not going that far. She's only going half of that far. She's only going 5/10. So I'm thinking that we're going to be thinking about half of 3, and that my answer is going to be somewhere between the numbers 1 and 2 miles total. Okay? Some of you might be thinking, Miss Connolly, you know what half of 3 is, but I want to show you that you can think of a range as well. So when I think about my estimate, remember this, I'm going to say, it might be, let's say it's going to be somewhere near 2. Okay, that might be my estimate. I know it's going to be less than 3 though. Okay, we're multiplying by a factor less than a whole. Anyways, so let's look at what repeated addition looks like with decimals, because that's something that you can use right now. So if I was going to add 5/10, there's plus 5/10, plus another 5/10, and plus another 5/10. And where do I end up landing here? 1 and 5/10. So then I check my estimate and say, does that make sense? Does it make sense that 1 and 5/10 is 3 groups of 5/10? And it does. Okay, so we can think about multiplying with decimals is the same as multiplying with whole numbers, except we're working with different size numbers. So I used repeated addition after I made a prediction what my product was going to be. Okay, so let's say I get really tired and I gotta make these a little bit smaller. let's say I get really tired and each day I'm only going to run 5/100ths of a mile. Okay, so first I ran 5 miles, then I ran 5/10ths of a mile. And now I'm going to be running 5/100ths of a mile. So there should be some predictions here. First, I want you thinking, if I did 3 groups of 5/100ths, is that going to be greater than or less than 3 groups of 5/10ths? Okay? Then I also want you predicting about 3 groups of 500ths. Think about the size of hundreds. And I'm going to try to make some tiny little jumps here on the number line. So if I go 500ths plus 500ths plus 500ths, I have added 500ths plus 500ths is 10/100ths plus 500ths is 15/100ths. Okay, so then I can think about whether my answer makes sense or not. Okay, so let's think about what happened as the size of our factor got 10 times smaller. So yesterday, if you're in my class, I made you watch the video about multiplying by powers of 10, and I want you to be thinking about how you see that here. Okay, when I was multiplying 3 times 5, I got 15. But then this factor got 10 times smaller, so my product had to get 10 times smaller. And as you know, when a number gets 10 times smaller, the value of each digit also gets 10 times smaller. So I had a 1 in the tens place here. It shifted to the ones place, which is the value of this 1 is now 10 times smaller than it was here. Okay, the 5 was in the ones place, it shifted to the tenths place, which makes it 10 times smaller. Okay, so as our factor got 10 times smaller, our products got 10 times smaller, and we want to think about what's happening to the value of each digit, because that's going to help us figure out where this decimal goes as we get to different numbers. Okay, so then I took 1/10 of this, so then I had to, of my factor, so then I had to take 1/10 of my product. So what I'm saying is my factor 5/10ths got 10 times smaller. My product then also had to get 10 times smaller. Since we're not exactly into dividing decimals yet, 1 5/10 divided by 10 isn't something that we've tackled. But something that you do know is that when a number gets 10 times smaller, the digits are shifting to the right and the value of each digit is getting 10 times smaller. So if you're going from 1 5/10 and you want to make it 10 times smaller, you think about the 1 was in the ones place, it needs to shift to the tenths place, and the 5 is in the tenths place, it's going to shift over to the hundredths place. Okay, so as we're thinking about what's happening, you want to think about the value of each digit and how it's changing and where the decimal goes. All right, so let's continue. So that's repeated addition. However, you know that doesn't always work when we're multiplying because we use numbers that are a little bit larger than 3 groups of 5/10ths. All right, so let's look at some of those. We are going to think first about 7 groups of 6/10ths. Okay? And I do not want you to add 6/10ths 17 times. Please don't do that. Okay? So I wanted you to see the connection that multiplication is still repeated addition, but we're going to go over what really needs to happen when we're multiplying with decimals. The first thing, your favorite, estimating. I really need an estimate first. Okay? So let's talk about estimating this. I'm going to think out loud. I wish you were here to do it for me because I love all the different ways that you estimate. But we can think about it a couple ways. When we estimate, we think a little bit about rounding, and we think about numbers that are a little easier to work with. So 6/10 I know is close to 5/10, which is 1/2. And that is something that's friendly that we work with fractions, and 1/2 is friendly with decimals, so 5/10 is something I can work with. So if I wanted to round this, I could think about 17 groups of 5/10, or what is half of 17? Okay, so I might say, I'm not gonna go exact here, everybody. I'm gonna say that I know that half of 17 is around the number 8, because I know that's half of 16, okay? Another thing that you could think about, perhaps, would be thinking about 20. So I rounded both numbers, okay? And as you know, I rounded 17 up, so when I get my final answer, I have to make up for that, okay? So when I think about 20 groups of 5/10, that's something we can do, or we can think of half of 20. Those are just two different ways to estimate, okay? We just want to know about what our answer should be so that we can double check at the end to make sure that we put our decimal in the correct place, the decimal point. All right, so I'm going to put my estimates up here to the side so we don't have too many numbers going on. And I don't want you to add 6, 10, 17 times. So what we're going to do is we're going to think about this as if it was whole numbers. Okay? So you can use any whole number strategy you want to solve 17 times 6. All right? A lot of us like the standard algorithm. I personally think this might be a little faster to solve in my head. So I'm going to think, not in my head, but I'm going to do it out loud for you. I'm going to think about keeping 6 whole, and I'm going to break up 17 by place value. I'll write down what I'm doing so you can keep track. So I'm going to think about 10 times 6, which is 60. I'm going to think about 7 times 6, which is 42. And some of you might be doing this up in your brain. Okay? So when I add these together, I get 102. Okay? So I know that 17 times 6, the whole number 6, is 102. So let's think about my estimates, shall we? I said that it could be 8 about the number 8. I think it could be around the number 10 when I was thinking about estimating. So when I'm thinking about where my decimal would go for this answer, I'm going to put 102 up here. I have to think, where would the decimal go that makes sense for these numbers? And I can rely on my estimate. Estimating is so important. Make sure you do it. So I know that my estimate was about 10 or around 8. It should be somewhere in there. So could I put my decimal here? And that makes sense? Not with my estimate. Could I put my decimal here? And that makes sense? I'm thinking it does. Okay? So that's one way we can think about where the decimal goes. What makes sense with these numbers? But we've done all of this work about what happens when a factor gets 10 times smaller. What happens to the product? It gets 10 times smaller. So 102. So 6 divided by 10 is 6/10. So I have a factor that's getting 10 times smaller. Look at, the digit was in the ones place. Now it's in the tenths place. The value of this digit got 10 times smaller. So I know my product has to get 10 times smaller. So what am I going to do? I'm going to think about where I would place my decimal to make each digit shift one place value to the right, and for the value of each digit to get 10 times smaller. And the 2 was in the ones place, now it's in the tenths place. That's where how I know where to place my decimal. 100 divided by 10 is 10. So as my factor gets 10 times smaller, my product gets 10 times smaller. So again, I used a whole number strategy Does not have to be the standard algorithm, friends. There's faster strategies, as you know. I estimated, and then once I had my answer for the whole numbers, I used my estimate to figure out where that decimal would go. Another way to think about it is what happened to the factor. When I think about the whole number, 17 times 6, I think about what happened to this factor. It got 10 times smaller. So what happens to my product? It gets 10 times smaller. Okay, so 102, I'll show you one other way, divided by 10, you all know will be 10 wholes and 2/10 left over. So if you're still struggling with where that decimal goes, you can think about fractions. All right, so if I know that I need to make 102 10 times smaller, I can divide by 10, and you know how to do this. You know how to take a fraction that's greater than a whole and make the equivalent mixed number. You know how to do that. So 10 and 2/10, do you see it? Oh my gosh, there's so much fun stuff going on right now. You can do this in so many different ways. All right, so let's do another one. So we are going to think about 120 groups of, let's do 8/10. I really don't want you to add 8/10 120 times, so let's not do that, okay? All right, so we need to do an estimate here. So we have 120 and we have 8/10, and I'm thinking that if I'm gonna estimate, I know that 8/10 is very close to a whole. So I'm thinking for my estimate that my product will be close to 120, but I also know it's going to be less than that because I rounded up to a whole number and this was only 8/10. So I know that it's going to be slightly less than 120. Okay? You know what I mean by slightly. Okay? So what can we do to solve? Well, we can do a couple things. First, I want us to think about this as whole numbers. So we're going to think about 120 times 8. And you should be thinking about what is the difference between this factor and this factor, because that's going to help us in the end to make sure our decimal's in the correct place. So again, standard algorithm, I know that you're going to be tempted to do it, but think about this. 8 times 100 is 800. 8 times 20 is 160. So 800 plus 160, 960. Okay, you have these strategies. I don't want you to forget about them, so that's why I'm reminding you. Okay, now, I know that my estimate, we talked about it, it's going to be less than 120. Okay, so when I think about 960, okay, and I'm just going to put 960 here to help us with placing the decimal, where would the decimal go that makes sense? So let's think about it. We have 120 groups of 8/10, and I know it has to be slightly less, a little bit less, not a bunch less, just a little bit less than 120. So I say, does it make sense to say 9 60/100? No, because we almost have one whole here, okay? So we almost have 120 groups of one whole. That is not going to be close to 9 60/100. So then I'm going to try here. And I see that it is 96 when I read that, 96 and 0/10, but we don't have to read the end if you don't want to. So then I ask myself, does that make sense here? Is it slightly less than 120? Yes. So my estimate helped me again. How exciting. All right, so other ways we can think about this. We have 120 times 8, and that's the whole number. Okay? Then we ask ourselves what happened to this factor. So 120 stayed the same, nothing happened there. 8 to 8/10. how much smaller, how many times smaller did 8 get? Well, I know 8 divided by 10 is 8/10. So when I think about what happened, my factor got 10 times smaller. So my product is going to get, you called it, 10 times smaller. And there's several ways we can think about it. If we have 960 divided by 10, because it's getting 10 times smaller, we think about how many groups of 10 goes into 960. 96. Okay, and you see the 96 up there. The other thing that we talked about, that you could think about, is what's happening to the value of each digit. When a number gets 10 times smaller, the digits shift one place value to the right, and the value of each digit gets 10 times smaller. So we used to have 6 groups of 10 here, standing for the number, representing the number 60. And 60 divided by 10, it got 10 times smaller, is 6. And that's in the ones place now. We had 900, and we know that 9 groups of 100, and we know that 900 divided by 10 is 90. So the 9 is now in the tens place. Okay? So, a lot of things to think about. Estimating is a must. It's going to help you make sure that your answer is correct. You are using whole number strategies. Okay, so I'm going to give you some to try at home. And I'm only going to have one factor have a decimal in it so that you can work on just that skill at one time. In the next video, I'm going to go over what happens if both numbers have a decimal in them. What are you going to do? Okay, so today's main focus is just thinking about using a whole number strategy to solve. But first, you have to estimate what you think your answer could be based on the size of the factors. Then, I want you thinking about using whole number strategies to multiply, and then you place the decimal. You think about what happened to the size of the factor, and you think about your estimate, because it has to make sense. Okay, so here's for you to solve at home. I want you to estimate first, what is 7 groups of 3 and 5/10? Okay, you are going to be tempted to add 3 and 5/10 7 times. I want you to think about estimating, I want you to think about multiplying, and I want you to think about placing your decimal. Okay, and just in case that you're not into that, I will have you think about doing 27 groups of 2800s. Okay, a little bit of estimating, please. Oh, sorry, not 2800s. Scratch that. I want you to do 27 groups of 8 and 3/10. And then I want you to do 1 and 4/10 groups of 15. And see what happens there. Okay? So, what's going to happen first is you are going to give me an estimate. I want to know what I want to know what you think the answer could be based on the size of the factors. Then, I want you to use whole number strategies to solve. And then you're going to rely on your estimate, and you're going to be thinking about what happened to the size of each factor. So for here, if you think about this as 7 times 35, you multiply 7 times 35, you use whole number strategies. I want you to think about what happened from 35 to 3 and 5/10. Okay, so give it a try, see what happens, and then we will go over some other situations in the next video. Okay, bye.